Hey guys, welcome back to Techogram. Today we're going to learn the second type of shortage of first method, which is preemptive. So let's get started. So in the previous video we have learned what is shortage of first non-preemptive, and in this video we will learn the preemptive. So we'll use the same question we used in the earlier video. So this was our question in the previous video, and as usual first we have to draw a Gantt chart. So always draw a Gantt chart so it makes the calculation easy. Now the Gantt chart starts from 0. We have to look which process arrived on the 0th on the timeline. So you can see from P1, P2, P3 only the P3 process is arrived on the 0th timeline. So we have to start the P3. If it was a non-preemptive problem, then we have to take the whole P3 from 0 to 5 because the burst time is 5, so you have to take from 0 to 5. But as this is a preemptive method, we have to see which has the smallest burst time, so you have to move it only by 1 millisecond. Now this 5 will become 4 because we have taken 1 here, and now you have to see on 1 because we are on 1, so there are two processes 0 and 1. So which process has smaller burst time? So on the 1 the P1 arrived, and on the 0 we have already P3 sitting in the waiting line, and you can see the P1 has only 2 burst time, so this one is smaller. So what you have to do, you have to do the same thing which you did for P3, just write P1 and move it by a single point, and now this 2 will become 1, and again you have to see from we reached on 2, so we have 0, 1, 2 point on the timeline, and all the 3 processes arrived. Now you have to compare the 3 process burst time and see which has the smaller burst time. So you can see from these 3 P1 is still the smallest, so now this will become 0 and this 1 will be written over here, and we have to again write P1. So this bracket is held by P1 and the P1 process is over, so remove it from here, and now you can see we have 2 processes, the P2 and P3, and we have to see which process is smaller. So now because there are only 2 processes remaining, you have to see which is the smaller. P2 has the smaller burst time 3, so directly write P2, and 3 plus 3 will be 6, so the header moved to 6th, and now only one process remaining, P3, which has 4 burst time, so 6 from 4 is equal to 10. If you have a question like we moved from only one point here and directly move the whole burst time here, because there are only 2 processes remaining, and even if you move only one, so this will become 2 and you just moved by 1 millisecond, so still this is the smaller one, so we have to again take this, then again take this. So instead of that, just take the whole burst time. Now we have to write the start time, waiting time, finish time, and turn around time. So always for the start time always look from the left side, and for the finish time always look from the right side. So start time of P3 you can see is 0, so write 0 in front of P3, and then for the P1 the start time is 1, and now P3, P1, and then P2, so the start time of P2 is 3. Now we have to find the finish time. So the finish time always starts from right, so you can see the P3 is ended on 10, so write 10 here, then P2 which ends on 6, so write 6 here, and then the P1 which end on 3, so write 3. So you can see the P1 is combined here, the P2 is here, only the P3 is divided in 2 parts. The first part is here and the second part is here. So calculation for all the process will remain same, but the calculation for P3 will change a little bit. So first we will find our P1 and P2. So 3 minus 1 will be 2 and 6 minus 3 will be 3. So the formula for waiting time is finish time minus starting time. Finish time separate starting time. So now for P3 what you have to do, because you can see there are only 2 parts, so there are 2 instances of P3. In the first instance the P3 ended on 1, and then in the again it start on 6. So 6 minus 1 will be 5. The process has to wait for 5 milliseconds to start, so we will write a 5 here. And now we will just submit 5 plus 3 plus 2 will be 10. And for the average turnaround time, the formula is finish time minus arrival time. So the finish time is 3, arrival time is 1. 3 minus 1 will be 2. 6, 2 will be 4, and 10 minus 0 will be 10, and the calculation for this will be 10 plus 4, 14 plus 2, 16. And now to find the average waiting time, which is asked in the question, average waiting time, so the sum of waiting time is 10 and the total processes are 3, so the answer will be 3.33 milliseconds. and for the turnaround time, the average turnaround time, the total time is 16, the processes are 3, and the answer will be 5.33 milliseconds. So this is how you can use the pre-emptive method of solving the shortage of first of CPU scheduling method. Hope you like the video. If you like the video, press the like button. If you have not watched the previous video, I suggest you to go check them out. It will help you to understand this video properly. Subscribe for more. Bye.